our perpendicular slope is then this. Putting it together as an equation, feel free to use your calculator to add 3 to 8/3. It's 9/3 plus 8/3, so that's 17/3, which is approximately 15 would be 5 and 2/3, which is 5.67. But you can do that on your calculator. Okay, so this is the equation of my line. So 5.67 would be like here-ish. Also, I have my midpoint. Let's talk about that for a second. So 5.67 would be here, and then a slope of down to 1, 2 over 1, 2, 3 is kind of like that-ish, those 2 points. So it'll look something like this. Also realize that once you have a point and a slope, and you're not asked to make the equation, you don't have to make an equation because you have all the information you need in order to graph that. And it's easy because 4, 3 is an easy point. Here happens to be the point of concurrency as well. And our slope is negative 2 over 3, so down 2 over 1, 2, 3. Up 2, back 1, 2, 3. So you don't need to make the equation of the line once you have the point and the slope. I'm going to draw it in lightly. I'm going to just put the points and we're going to talk about this for a second. Realize in your Voronoi diagrams that I've lost like all of my stuff. Sorry, I can't find an eraser. Here we go. That we're trying to create cells around these sites, right? So our cell between A and C is being blocked off by here. But this is the part of the line that we care about. Once it hits the point of concurrency, any extension past the idea of AC, past that point of concurrency, no longer applies. This line does not split a cell between B and something else, it's just extra. So that's the one last thing that you have to do when you're making your Voronoi diagrams is decide what part of this line is extra. So if BC, if this is the perpendicular bisector, once we hit the point of concurrency, anything after that is no longer needed. So make sure the point of concurrency only discusses the B and C. The perpendicular bisector only discusses B and C. It doesn't go past that and try to split up something else. So then once I go in here and draw this, and I'll draw it all the way through so we can go back and erase, see that this has broken up the cell for C into something that's not correct. This perpendicular bisector is splitting up between A and B. It's splitting that piece in half. So once it hits the point of concurrency, it's no longer needed. And so that is your trifecta here. Now we have one more point we need to add, but it's always better to start with 3 points, establish that relationship, and then add 1 point at a time if you have more than 3 points on your Voronoi diagram. Okay, so now I've done this. Now I'm going to establish a triangle with D. And hopefully it's pretty easy to see that the triangle we would talk about is BCD, because A wouldn't count because C is in between, right? Kind of like our problem that we did on the previous page. So I want the perpendicular bisector between all 3 of those points. Well, I have the perpendicular bisector between B and C. Fantastic. C and D and B and D are not easy, at like horizontal or vertical, but all we need to do, as we figured out previously, is just find the midpoint and just find the perpendicular slope, and we don't actually need to make the equation unless we're asked to make the equation. So for BD, the midpoint is and the slope So then our perpendicular slope is, oops, there you go. All right. So midpoint between B and D is 10.5, 4.5. Not quite as easy as before, but we're going to go up 3 over 1. Or we could go down 3 and back 1. And again, I'll draw in my lines lightly. And then I need to do between C and D. Interesting, pretty familiar, but that just happens to be this case, is that it works like that. So I'm going to just take my midpoint, which is 10.5, 1.5 here, and I'm going to go up 3 and back 1, or down 3 and right 1. Okay. So now I've got 3 perpendicular bisectors, and there are too many lines, right? It doesn't look like a Voronoi diagram. It just looks like a bunch of lines intersecting. So we go back and we spot the perpendicular bisector, and we say, where do we stop caring about this perpendicular bisector? So for instance, between B and C, this is our perpendicular bisector between B and C, and we stop caring about it after the point of concurrency. So we care about it here, but we don't care about it here, so that's where I erase it. The perpendicular bisector between C and D is this guy right here. So being able to say I care about it here, but afterwards I don't care about it, so that's where I erase. Perpendicular bisector between B and D, after the point of concurrency, don't care about it, and I erase up to there. Going back in and redrawing them darkly, I think helps, because it makes it feel more like a Voronoi diagram. And there you go. It's kind of dealing with triangles at a time, finding all of the perpendicular bisectors, going back in and saying, where do we care about it? Really finding where it is in the middle, find out where it intersects, and then erase everything else after that. And then if you have more, creating more triangles after that. Okay, that's all we're going to do for today. We're going to talk about next class why. We're going to talk about why we care about them, about all of the applications. We're going to do a few more practice problems, and we've got quite a few IB level problems that I want to get to, but I'm also wary of making your notes too long. So we're going to try it out and see how far we get next time. Good job.